we're going to be talking about lesson 7.3 and 7.4. And that's really just going to cover different properties and how we can manipulate the numbers and what you can legally do with numbers, I guess you could say, based off of math rules. Okay? There are several math rules and rules that you can do with numbers and things you cannot do with numbers. We're not going to spend a ton of time on this front page of your purple notes right here. Where I'm going to run through these. This is kind of more of like vocabulary that you're just going to have to memorize on your own. But we are trying to make equivalent expressions using these properties. Get a pen here. All right, so equivalent expressions. Equivalent means what? Equal. We're trying to make expressions that are equal. The first thing we have are it's called your commutative properties. I would circle that word because that's a vocabulary word that you're going to see. Commutative property means that you can change the order when you're adding or multiplying, and it's not going to change the answer. You can change the order, and it's not going to change the answer. For example, what's 2 plus 3? 5. What's 3 plus 2? 5. It doesn't matter which one comes first, you still get the same answer. Same thing with multiplication. If I do 2 times 3, I get 6. 3 times 2, I get 6. It doesn't matter the order. When order does matter is when it comes to subtraction and division. Those you can't get out of order. Those have to stay the same. If I do 3 minus 2, I get 1. But if I do 2 minus 3, I get negative 1. Those are not the same. These are not commutative. The numbers cannot change order. Same thing with division. If I do 20 divided by 5, I get 4. But if I do 5 divided by 20, I'm going to get a decimal. I'm going to get part of an answer, right? A part of a whole. They're not going to equal the same thing. So it only works for addition and for multiplication. You also have what's called the associative property. When you talk about associate, that's like who you hang out with, who you talk with, the groups that you're with. Associative is talking about the groups. If you see parentheses, it's going to be talking about associative most likely. Okay? What this means is if all the numbers are being added, it doesn't matter where the parentheses go. Or if all the numbers are being multiplied, it doesn't matter where the parentheses go. Okay? That's what those two things mean. And then it gives you a few more examples down below.
So you can just pick one again.
All right, if you turn the page, the next property we have is called the addition property of 0. Meaning, anytime you add 0 to anything, does it change the answer? No, it's just itself. So really, you don't even have to add 0. It stays the same. And then you have the multiplication properties of 0 and 1. Meaning, if I multiply anything by 0, my answer is 0. If I multiply anything by 1, my answer is the same number, right? Whatever you're multiplying by. So those are 4 properties that you're going to have to take the time to memorize on your own that you will see again. But these are also properties that you have seen in the past. We are going to work on one property today, which is a newer property that you'll see in 7.4 called the distributive property. Distribute means to pass out or to hand out. When you want to pass it out evenly. So if I give one kid M&Ms, I got to give the other kid M&Ms, right? So if I give one number a 4, I've got to give the other number a 4. Okay? And we're going to model this here in just a second. But the distributive property is what we're going to talk about today. So you can actually put your purple notes to the side for a second. And you're going to get out your algebra tiles. Now, it's important that you keep up with these algebra tiles. They are not the cheapest thing in the world. So if something falls on the floor, please pick it up. Okay. You should have in your bag, you should have 4 large squares. Okay, I'm going to put it on my whiteboard so I can get it easier. You should have 8 long ones, and then you should have 21 smaller ones. Some people have 22. It's okay if you have 22, but you should have at least 21 of the little pieces. Okay? So you're going to kind of just set those over to the side. We don't need these big squares today, so you can actually put the big squares back in the bag because we're not going to need those today. All right. So we're going to build some examples of the distributive property using our algebra tiles. So the first problem we're going to start with, and I'm going to turn off this front light so there's not a glare. Okay. I want you to copy on your board 3 parentheses b plus 5. What? I want you to write this problem at the top of your board. Everybody should have this problem at the top of their board. You're going to have to leave your whiteboards flat on your table because we're going to build on top of our whiteboards. All right. We're going to look at the group first. Parentheses are grouping symbols. So this is the group. This is what we're building. Okay, we're building b plus 5. Our rods here are going to represent our variables, the letters. And our little ones here, our little squares, are going to represent the ones. Okay, I'm only going to use green for the rods right now. Make sure they're all flipped to the green because you're only using green. All right, I have 1B. So this represents B, and I have one of them. Okay, so this is B. And I have how many ones? 5. So I need 5 red ones. So make sure they're red. 5 red ones. All right, your board should look like mine.
Does it have to be lined out like yours?
No, it's not. All right. This is the group. The number on the outside of the parentheses tells me how many times I'm going to need to build this. So how many times do I have to build this? 3. So I'm going to come in here and build it 3. So that I have 3 groups. Three, 4, 5. There's 1. 1, 3, 4, 5.
Can we do it with like we're gonna do the
You can come back and go B, 5, 5. All right. The directions of this prompt is to simplify using the distributive property. This problem right here represents this. Okay? We have 3 groups of this. So we have 1, 2, 3 groups of b plus 5. Simplify means to make it smaller. So we're going to shorten it. We're going to put together the things that are the same. So I can put these things together. How many b's do I have?
3.
So I have 3 b's. And then I'm going to put all my ones together. And how many ones is that going to be? If I were to count that out, there would be 15 ones. Oops. What operation sign is happening between the b and the 5?
Addition.
Addition. So that means addition's going to hold it together here. This is the simplified version of this up here. Now, that's with a model. How do I do it by just doing math? If I take my 3 times b plus 5. Okay? What I have done is I've made 3 groups of b and 3 groups of 5. I have done b 3 times. I have done 3 times b. Okay? And I have done 5 3 times. So 3 times b equals 3b. And 3 times 5 is 15. And when I add that together, I have 3b plus, which is what we did right there with the model. So we're going to practice modeling it and using the math. Model it and then the math. Okay? So put your pieces over to the side. Clear your board. And we're going to try another one. All right, we've got 2 times the group of x plus 7. Okay? 2 times x plus 7. So we're going to build this. All right? We're going to start with our group. We're focused on the group part, what's in parentheses. So we're going to let our green rod represent the variable. So we have 1x. And how many ones? 7. So I need 7 ones. 1, 2, 3. 7. 7 ones. So I have x plus 7 being modeled here. How many times are we going to do it?
2.
The outside number tells me how many times. I'm going to do it 2 times. So I do it.
What is the white, yellowish looking color on the squares and then the
It can help you represent negative numbers.
What?
It can help you tell the difference between negative and positive. The colors. But we're not there yet. We're just focused on
Are we gonna do negative and positive?
a little bit. The same thing represents negatives and positives. All right. So if I combine this together, how many x's do I have? 2 x's plus how many ones?
14.
14 ones. If I wanted to show that the math way, if I had 2 times x plus 7, I would distribute my 2 to the x. I would give the 2 to the x. So 2 times x. But I also have to give it to the 7 because we built both pieces, right? So that 2 had to go not only to the x, but it had to go to the 7. So 2 times 7. All right, so 2 times x is just 2x plus 2 times 7, which is 14, which is the same as what we modeled, right? Okay, put my pieces to the side, clear my board.
Can I just, once you write it, can I just say it?
No. All right, 2 times 4x plus 7. Or since we just did 7, let's do 6 instead. All right, we're only focused on the parentheses, the things inside the group. So how many x's am I going to start with? So 1, 2, 3, 4. All right, so there's my 4x. And how many ones? 3, 6. So this is the model for what's in parentheses. I have 4x plus 6. How many times do I have to do this? Twice. I have to do it 2 times. Well, how do I know it's 2 times?
Because the 2's on the outside.
The outside of the parentheses. So I'm going to build it 2 times. All right. If I put this all together, how many x's do I have?
8.
8x. How many ones do I have? What goes in between them?
Plus.
Whatever's up here. Plus. So 8x plus 12 is my answer. It can't go any further. Can we put this and this? Can we put those together? No, they're 2 different things. These are rods and these are tiny ones, right? Are these the same thing? So can they go together?
No.
No. Only the same things can go together. All right, if I wanted to do the math version of this, I would have to distribute the 2 to the 4 using multiplication, right? Isn't that what we did? We did how many times? So 2 times 4x plus 2 times 6, right? This gives me 12, and this gives me 8x. So 8x plus 12, which is the same thing here. You have got to remember to give it to both. Okay, that's why we're building it, so that you remember to give it to both things, because you'll go really fast and try and punch this in your calculator and you won't give it to the second. Okay?
You have to do the math way and the original.
We're working on this. Eventually, all you'll have to do is the math way. Okay? But I really want you to understand what's happening with the models right now, because you may be asked to model it at some point, and I want you to understand what's actually happening. All right. We're going to do some of the problems from your purple notes that are on page 260 at the bottom there, starting with 1. No, we're going to still use our models for now. All right, I want you, we've got 4 times A plus 3. 4 times A plus 3. Or some people would read it as 4 times the sum of A and 3. Okay. What are we going to start building first?
The 4.
Not the 4. We look in the parentheses first. This is what's being duplicated. This is what's being distributed. Okay? So we have how many A's? 1 A. And how many 1s? 3 1s. How many times am I going to do this? 4 times. Instead of having to make you keep building it over and over 4 times, you can if you want. You can put times 4 and times 4 here if you want. Okay? So this represents A, and this represents 3, right? So A 4 times is going to be what? 4A. And 3 4 times is going to be 12. And then I add them together. And your answer is 4A plus 12. All right. If I had 3 times F minus K, 3 times the difference of F and K. Three times the difference of F and K. Now, we have 2 variables going on right now. So what we're going to have to do is we're going to have to use the, we're going to have to use both colors, okay? So let's let the green represent the F, and let's let the red side represent the K. All right. How many times are we going to have to do this? 3 times. So 1. Oops. So what is this going to be? F times 3, which is going to be 3F, right? And how many K's?
K.
3 K's. And we're going to minus them. Now, can I put these 2 things together? Because they're different colors, right? Are they the same? Represent the same thing? No. They represent 2 different numbers. F could represent 2, and 3 and red could represent 4 or 12 or whatever. Are those the same numbers? No. Okay. So this right here is all our answer would be. 3F minus 3K. If you did it the math way, I had 3 times F minus K. I'd have to go 3 times F and 3 minus K, times K, my bad, times K. And we're subtracting. So 3 times F is 3F, 3 times K is 3K, with a subtraction between them. Okay. All right. I'm going to show you one more, and then I'm going to let you practice on your own, because I feel like y'all kind of got it. Do you feel like you kind of have it?
Yes.
Okay. All right. If I had 2 times 4 plus A plus 6.
Is that A?
Yes, it's an A.
Can you do anything?
You can use whatever letter you want it to be. Alright, we're only focused on that part right there. So let's build that part. So we're going to build it the same order it's in. So we got 4 plus an A or an X or a C or whatever letter you want to use plus 6. How many times are we going to do this?
2.
2 times. It tells us right here we're going to do it 2 times.
We don't have enough things.
You do. This represented 4 plus A plus 6. And we did it 2 times. Right?
Mm-hmm.
So if I put these together, how much is that? 8. And if I put these together, it's
2A.
2A. And if I put all of these together, it'd be
12.
Can we go any further? Can we put anything else together?
No. Well, you can put the 4 and the 6 together. No.
Aren't these and these the same thing?
That's what I said.
Can you put those together?
Mm-hmm.
So I've got 8 here and 12 here. So how many red things do I have?
20.
20. 8 plus 12 is 20 plus 2A. That would be my answer. I could do the math written out version of that. I can distribute the 2 to the 4 and it'd be 2 times 4. And then I have 2 times A. And then I have 2 times 6. Well, 2 times 4 is 8. 2 times A is just 2A and 12. And then I can put my constants together, which would give me 20. So it would be 20 plus 2A, which is the same thing, right? All right, we've got a few minutes before we leave. So what I want you to do, if you turn over, you see the puzzle time. I only want you can just do the math way, or if you want to build it, you can build it. But I only want you doing this top part right here for right now. So numbers 1 through 12. Okay. Please make sure that all of your pieces get back in your bags and that you zip them tight for me so that we don't miss any pieces.
Okay.